Okay, welcome everyone to our teacher workshop from the Earth Science Information Partners Education Committee. Today, we're going to have 3 separate sessions, I think, as you saw in the agenda. Lauren, if you could go to the next slide. Oops. I just said this session is supported by the Education Committee. Our goals today are to enhance your ability to teach with data, raise your awareness of tools, data sets, and techniques to support your work, build a collaborative community, and we want to have fun. Next slide. So we're going to take just a couple of minutes to introduce ourselves. If you could share your name, where you're teaching, what you teach, and what you hope to get out of our time together. I'll go ahead and start. I am Carla McAuliffe. I'm with the Institute for Global Environmental Strategies, and basically I teach teachers to use data in their teaching. And I'm hoping to get innovative ideas from you as we play around with some of these data sets today. So if you're in the room, I'm going to mute myself. You'll want to, well, you can come over here and speak, but we want to be able to have the online people hear us. Yeah, be easier. Yeah, I'll step over here. I can start. Talk into it. Use your teacher voice to get into the computer.
Is it turn on the voice? It's on?
It's on.
Okay. Hi, my name is Lalita Kempka. I teach in Katy, in Texas, Katy ISD. I teach 6th grade science. I want to implement data into my classroom to my 6th grade students. How can data be more interesting and engaging to them so they can use in their projects and in our science curriculum? Thank you.
Hi, this is me, Berta Martinez, and I teach the Apocunimic School District in Delaware, Spanish immersion science. And what I hope is to be able to get the data, digest it, and give it to my students so they can relate the data to their daily lives. Thank you.
Hello, my name is Alton Wimberly. I am a teacher at Tompkins High School in Houston, Texas, in the Katy ISD district. Formerly, I've been a teacher of physics for 4 years at May Creek High School. This year, I'll be transitioning over to be the aquatic science teacher at Tompkins High School. One thing I want to get out is definitely how to look at data better, how to read it, how to analyze it, how to move forward with it, and give my students the comfortability to use it more without being so fearful of the data.
Thank you. And I had my video off. I'm going to pass it over to Don.
Hi, I'm Don Haas. I'm the Director of Teacher Programming at the Center for Climate Change Education at the Paleontological Research Institution and its Museum of the Earth as well. I'm a former high school, mostly earth science, a little bit of physics teacher, and also a former professor of education. I've been at PRI for 17 years now, and I will pass it to Lauren. And mute.
Great. Nice to meet you. I'm Lauren Brazzi. I'm with American Geosciences Institute. We're with the Education and Outreach Department. I was a former high school teacher. I taught high school science. I did chemistry, physical science, and astronomy. I spent some time out in the field with the EPA Office of Research and Development, and then came to AGI about 4 years ago. And now I've been working in helping promote and distribute geoscience materials for K-12 educators. For today, I hope to work with these educators and get them as many resources as possible that they can utilize in their classroom without being extremely overwhelming, since I know that the 3 of us, have a ton of resources to share. And so just being able to really interact very intimately and answer questions and make sure that everyone's able to leave here with an agenda and things they can do and implement in their classroom coming up, starting for some of us on Monday as the school year begins.
Lauren, I think there's one more slide.
Do you want Shelley to introduce herself?
Oh, whoops, sorry.
Shelley, you want to pass it off to you if you don't mind?
Sure. Hi, everyone. There is an echo back there.
Everyone mute besides me.
We're all muted.
Okay. Hi, Shelley Olds. I'm with EarthScope Consortium, which is focused on geophysics, mostly seismology and geodesy. And my role there is leading the education development side of curriculum for middle school, high school, working with teachers in collaborative environments to make data make more sense and to make data tools that people can actually use. So lowering the barriers to getting to data. And yeah, hopefully, fingers crossed that our grant is let by NSF so that we can continue this mission and provide free resources to everyone. What I want to get out of this is always really cool to learn new techniques and new ways of doing things and understanding and pulling that into the pedagogical structures and content structures that we do, and interacting with teachers as much as I can. So thanks for letting me join.
Thanks, Shelley. And now we have one more slide. So we will talk more about this later, but I want to remind the teachers in here, you've heard about this several times, that today we're going to be making our Funding Friday posters. I put a couple of examples here. These were the last year's winners of the Funding Friday, 2 teachers that were unfortunately not able to be here. The other opportunity that you'll have, we'll also talk more about later, are school year implementation grants. So if you implement something from any of these sessions today, you can write up a little sort of mini report and there will be some funds available for you. We also do out to lunch webinars during the school year. These are 15-minute webinars that have 10-minute presentations and 5 minutes of Q&A. And we also record those because lunchtime isn't the same across the entire country. They're held at noon Central Time, but that could be a different time you might be teaching. And with that, I'm going to pass it off to Lauren.
All right, we're all set up. Great. Well, like I said, I'm Lauren Brazzi with American Geosciences Institute. I'm going to talk with you guys today about stormwater solutions, designing and using rain gardens in education. And I think, at least for those of us in the room, I presented a poster last night. I think we all got a chance to kind of talk a little bit about the project, but I'm excited for the next hour or so to really get you guys hands-on with some of the data components of the project and exploring how you can share environmental data in the platforms that already exist with your students, and maybe some project ideas going forward. So American Geosciences Institute, I've shared a little bit about, we are a nonprofit organization. We're a federation of member societies. And so a lot of groups, they work with individuals, but AGI works with organizations. So ESIP, PRI, EarthScope, all the different organizations that do geoscience work, we help promote that work and share the resources. And I'm part of the education and outreach department. So there's 4 of us really working to do that. And there's 2 other departments at AGI. There's workforce development. So K through 12 outreach department, we work with any age person up until they declare that they are a geoscience major. And then our workforce department takes over because they can serve their needs better. And then we also have a department of scholarly information, which is helping get across and share different geoscience work. Some big programs within the education arts department right now, we have Earth Science Week, and we're going to talk more about that later. Both Carla and Don are really involved, and Shelley, I'm sure, with EarthScope Consortium in Earth Science Week. And our theme this year coming up in October is energy resources for our future, and we'll explore some data related to energy later today. And then a new program, which you guys, the 3 of us in the room, 3 teachers in the room are a part of, is the Geoscience Experiences for Teachers out in the field. And so AGI really has recognized the benefit of getting teachers interacting with professionals. And this is something that we want to continue. And so the three of you in the room right now, it's great that you're here, you're interacting with professionals, but if any way that AGI can continue that collaboration and involve you and work with professionals out in the field, we have a couple other programs that I can talk with you guys about more casually today. But that's why we have 3 teachers here today. And so thank you to USGS for really prioritizing mapping and field work and getting teachers, again, interacting with professionals. So I'm going to start today. We've touched on this a little bit just in casual conversation, and Shelly in the chat, you can participate as well, but take about 30 seconds and think about, what do you think are some of today's biggest problems? And then we'll share out in about 30 seconds. And Shelly, if you would like to add things to the chat, feel free, and we can share those out as well. Or you can unmute yourself. All right, I'm just gonna go around the room. Bertha, we'll start with you. Give us something. What do you think some of today's biggest problems are? Okay.
Disconnection from reality that
Mm,
is
okay.
and we talk about whether the students doesn't know how to measure precipitation or temperature, or even that we have at least 2 ways to measure temperature. This is my room,
Mhm.
Celsius and Fahrenheit.
Mhm.
They start with this
Yeah.
So I want to be sure that they know the basics. So they are going to be able to understand the data when it comes to college.
And Shelly, that was just a disconnect between the real world and the data and how it's really connected. So students starting really basic and then building that complexity up, that they're not able to make that leap and understand that connection. So very data focused, which makes sense because we are at ESIP conference. So thank you for that, Bertha. Alton?
I would say that I know a lot of our students don't know how to read data and break it down and understand it. And I think that comes from a lack of teachers not knowing how to read data and understand it. We're not taught how to break it down. We're taught to teach it. We don't know how to break it down.
So disconnected, being able to break down data, starting from the students, but also just inherently in teachers, therefore not being able to communicate that issue. Awesome. Lita?
When students look at the data in class, they set down like what the student number so that they know. So for them to do data, they need to find something like basic or exciting something that they can start utilizing data and data is because I'm thinking about for the So I think they do all this stuff, but we don't kind of measure something to work that. So I think it's good to learn how to collect data and then we over find out what data is kind of telling them.
Yeah. So Lolita had shared about data visualizations and just the lack of being able to read them. Students and people in general actually making good progress and doing great work, but then not able to share that in a visual way that seems scientific with some sort of visualization. I applaud all of you for focusing on data. We're going to even think bigger than data and go more generally into some of the issues that people think. And Shelly, I'm sorry, I forgot to share. Yours were climate, fragile governance of structures, lack of support for education systematically. And that is probably completely in line with what you guys see. It's a sustainable development goals. And so the specifics that we were talking about in the room, I think really fall into the details of some of these goals that in 2015, the United Nations developed these sustainable development goals as a global way that we can talk about some of the world's biggest issues. And we can see on the 17 that are listed and that exist, there are many that relate to earth science education. What's even more exciting is that if you don't inherently think of it as being an earth science issue, if you get into the weeds, all of these different goals have targets and indicators, which really go through the specifics about what the goal means and what some of the initiatives are. Many of them on like a second level or even a third level do relate to earth science education. So they can be incorporated into the into students, into the curriculum, into conversations. And we at AGI have found it's an amazing way to motivate students as to why they should learn these topics and what's the importance behind the topics and the content they're learning. Because students nowadays, especially, they know about problems, but that's inducing a lot of anxiety for students. And this is a way to talk about the issues that exist, but also action oriented. And so Lolita was sharing about a project where they're cleaning up waste and reusing it to make art, completely in line with Sustainable Development Goal 12, responsible consumption and production, into handling that waste, ensuring that we have a cleaner environment, and also what can we do with that waste at a surface level. Now, if we dig into the weeds, there's also a huge component about fashion, because the fashion industry is one of the biggest waste producers. So there's a lot of information that maybe students aren't aware of that ties to the content we're teaching, and you can use the Sustainable Development Goals as a framework for teaching to your students. And we have a lot of ways that we at AGI have done that, and I can give a whole presentation about that, but we're gonna move on just for the sake of time, and I can talk more about it with you guys later. One of the data related components of the SDGs that's really great is from one of our partners, Earth Observations, for the Sustainable Development Goals. There's an interactive map I can click on, and in the agenda, I believe there's a document, Shelley, and forever in the room too, that you can go to and click on a lot of these links. But it's a way to kind of track the SDGs, and you can go, let me see if I can put my screen over, but it's, again, a way to include data in the conversation. So how are countries doing? All the SDGs are posted at the bottom, and you can kind of click around. So like clean water, we can see that some of the countries are doing better. We can click on a country if we want to learn more and look at the indicators about specifically what has been tasked, what the country or the world has been tasked with, and how the countries are doing. So as you're having these conversations with students about the Sustainable Development Goals, note that there is real data that's behind some of these indicators, and there's organizations such as the EO for SDGs, Earth Observations for SDGs, that are tracking it. So just a way, again, to talk about the Sustainable Development Goals and be concrete with what you're saying versus just some initiatives. And so related to the work that I'm doing today, or we're talking about today, the resilience, innovation, and nature-based stormwater solutions, and it's a fancy way to try and get rain in the title because we're talking about rain gardens. So we're going to call it the Rains Project, but looking specifically at SDG 6 and SDG 11 was one of our goals with some partners. And we're working with schools and communities specifically around the Chicago area because that's where I'm located. So it's more economical for me to just travel to schools in that area. And we're helping bring to light stormwater management in especially the Chicago area, as you can anticipate in a lot of urban areas with a lot of pavement. Stormwater flooding is an issue, as I know that it's been all in the news as well. So and this has been around for a long time. Rain gardens are not new, but the aspect that is new is just trying to incorporate data collection in the recognition of how data rich these activities could be with students. So it helps preserve the rain garden, because we've seen a lot of issues where a teacher gets really excited, a rain garden's installed, it's a really data rich, really hands-on activity that lasts a year, and then it kind of goes by the wayside. The teacher retires or leaves, or there's nothing to continue doing with a rain garden. So it's forgotten about and then kind of ignored. So if we can incorporate data component into a rain garden, it's going to help the project last a little bit longer. This work is supported by ESIP under a small lab grant. So I'm excited to be here today to share about it. So we're going to have 3 components, and we're going to spend, I know I'm already, oh my goodness, 11:20. So we're going to spend probably most of our time about talking about the designing a rain garden feature, because I've talked with the 3 teachers in the room and they do not have rain gardens at their school. And then at the end, I'll touch on monitoring and using an existing rain garden as a teaching tool, because that is something going forward that we're going to be doing this fall with the schools that have installed rain gardens. Hello. Hi, Mark. A rain garden. We're going to get into it. We haven't talked about that yet, so we're going to catch you up. So designing a rain garden, a hint, this is one. It's an image of it in the ground. It's essentially a depression, but even going back, we're going to jump back to that in a second, but the curriculum initially is just to help explore stormwater challenges. And so once again, talking about that pavement aspect, the curriculum is going to help students and teachers analyze local data, because teachers and students are more motivated when it is local information, it's directly affecting their community. They also, because we know getting students involved in data collection and analyzing data is important, but students typically are most invested and interested when they can get their hands on something as they're extremely tactile. So we're going to do a quick activity today about soil analysis, but this curriculum does integrate fieldwork into the curriculum, and then designing and potentially installing a rain garden on school grounds as well, which we have a couple schools that will be doing. And here's the outline that we're just going to run through quickly. At AGI, we typically tie everything to next generation science standards because they're most common across the country. And if states are not adopting specifically NGSS, they're adopting components of it. So again, it's just a way that we can tie it to curriculum. So take 5 to 10 seconds. Now we each have a partner next to each other. If Alton and Lolita and Bertha and is it Mark? Sorry, I forget. Mark want to talk about just a quick question. And Shelley, if you want to throw in the chat, just what is stormwater runoff? Why is it a problem? And then also, what are some solutions that you can think of and what related data might be helpful to look at? And that's making a ton of assumptions. If we were in a classroom, would we immediately start here with students and spend 5 minutes? No, we would have way more buildup than this, but we're teachers, adult learners going through this pretty quickly. So just keep that in mind as we're reading this session. It's very abbreviated, taking into account adult learners, not middle or high schoolers. So take about 10, 20 seconds, talk with the person next to you about maybe, let's pick 2 of these questions that you guys could discuss. About 5 more seconds. And as you guys are wrapping up, I'll share Shelley. She shared stormwater runoff is rain or hail or snow hitting the ground and running across the surface and into storm drains, streams, oceans, etc. And pollutants. Think about all the yucky stuff going into the water. Thank you, Shelley, for that. And with that, I'll send off my animation here that I think is the initial conversation with students. And usually it takes about half class to get to this point. About storm occurs, where does water go? In a great way to do this, and I'll jump around a little bit here just because the conversation is using an Enviroscape. Has anyone ever seen an Enviroscape before? It's a very cool model. They're very expensive, so I don't recommend buying one for your classroom, but most soil and water conservation districts have them. We're actually going to go on our field trip on Friday. So I'm taking the group of teachers out around town tomorrow. Bertha, I don't know if you're going to make it because it's by the airport. So it'll probably be after our split, but we'll go and see an Enviroscape in person so you guys can see how it works. But it's kind of like a big, I mean, you could kind of see it looks like a toy. It basically shows how water transports over areas. And there's tips about using like sprinkles and showing pollution and spraying water. And you can kind of see it's a little bit it's very game-like and interactive with students. And so they can set up houses, they can pour molasses or syrup areas and see how it travels. Really helps learn about topography. And then the green areas on an Enviroscape are more porous than the gray areas. And so they can actually see how water can get absorbed into the ground versus over the gray pavement, it kind of travels into the water and that everything kind of collects at the bottom. So it's a great tool. Again, a lot of conservation districts have them and will loan them out to teachers for free. And so one of the aspects of AGI, again, is that we want to make sure you guys feel comfortable reaching out to people. And so there's always been a barrier between educators and professionals. Well, I don't want to reach out. What if they say no, or they're going to say no? Whereas professionals always are looking for opportunities for outreach, and just takes bridging that gap and breaking that boundary. So always feel free to reach out to people like, I see you have an Enviroscape. Can I borrow it one day for class? And they probably will say, great, can I come in and do it with you and share? Even better, come in and lead my class for a day. That's awesome. So again, that's just a pitch, but this is how we've introduced this activity with students in the past. If something similar to an Enviroscape, whether that's borrowing that from, like I mentioned, a local location, whether it's a museum or a conservation district. Another way to do it cheaply is with sponges and clay. And so we've also made a model in like a baking sheet and taken sponges that are green, just again, because grass is green, and then like gray clay, or even like Play-Doh, homemade Play-Doh. If you make it out of flour, it's white. And we've created kind of our own little model. And then you just have a spray bottle and use sprinkles. And again, very cheap compared to purchasing a very expensive, but very realistic and fun EnviroScape model. So again, we start with an introduction, this curriculum to stormwater, and this is an easy way to do that. I'll go back one slide if I can, because one of the ways that we did it, introduced stormwater runoff with a school that we had installed a rain garden, was to look at a local creek. And so this is in Cincinnati, it's Cooper Creek. And you can see the image on the left. It's the same picture one day. I don't even know if it's one day. It's not exactly in this picture, but it gets very flashy. So you can see on the left, it's low stream. That's typically what it looks like. And then after it rains, the culvert flushes all that stormwater runoff from the school and the community, and it fills up extremely fast. And we have all this data to track it when I was with the EPA, or when I was working with the EPA Office of Research and Development. And so because it was such a flashy area and it was really hurting the ecosystem right there and the wildlife, the initiative from the conservation district was to install these rain gardens in order to slow down that flow. Because the goal of a rain garden, it's a depression, and its goal is to just slow down the water. We don't want it to enter the storm drains and then rush into the rivers. We want it to get into the ground, to seep into the ground, so that the grass and the soil can filter and clean the water before it reaches the groundwater table and help get rid of those pollutants. And again, I'm telling you this in 2 sentences. With students, that takes a whole lesson. Also fun for us to discover was that the water was seeping into the sewage, and you can see that's just completely sewage overflow happening in the river because of the heavy flows. And so that's disgusting. We have baby wipes coming out the wazoo right there. It was just wonderful to see and smell. So it's a great way to get kids interested and invested in the issue, is that this is happening, I don't know, a mile away from their school because of what's happening above in the topography where they are located. So that's how the curriculum starts. There's lots more details online. This is all available to anyone that they want to use. Typically the next day, we actually look at digital tools and we take field observations of their area. And so on your computers, I think we'll do this for a really quick amount of time. We are going to look at specifically one of the schools I'm working with, which is Downers Grove North High School in Downers Grove, Illinois, and look at some of the data that's available for you to look at with your students at your school. So what we've done with kids is we've taken them to EnviroAtlas. So if you guys want to get out your computers, if it's not out right now, and in the SCED, there's a link to an agenda, which has a link to another document. Another easy way to get to this app is just say EnviroAtlas on Google and click go. And then let's look together about these types of data platforms. And so we're going to look at a bunch today. It's not going to be, you're not going to become proficient. Obviously, we have less than an hour left. So we're going to just kind of go through them to expose you to these different data platforms. But again, just know that you'll have time later to kind of explore. And then we at AGI are always available to answer questions. And so if you go home and look at these resources and want to talk more, just email me and we can meet for our own time online. So in the EnviroAtlas, once again, let me get there, find my mouse. Whoops, I'll do soil in a second. Let's see if it'll let me click. No. So I'm going to pull up EnviroAtlas, and this is an EPA tool. So fingers crossed we still have this soon. And I'm going to type in at the address bar. Let's all start with Downers Grove. I know that the initial thing is to like search your house, which is what students always do. And we let them typically like look at your house because that's exciting, but we're limited time and you're adults. So you can look at Downers Grove with me, and then we'll have time at the end, hopefully, to look at your schools as well. And we can zoom in. I can't really see. There we go. If you just click in Downers Grove, it brings you almost exactly to the high school. And so once you kind of type in your location, there are all these different collections that pop up in these different layers. And so once you're in EnviroAtlas, you'll just click, again, type in Downers Grove, Illinois, and then click kind of the Apple button, which is the EnviroAtlas data. And there's a ton of stuff you can look at. We're going to be only focused on surface cover because through the lessons with students, we help them realize through the EnviroScape or whatever activity we've done to engage them in stormwater runoff that It really is about the surface cover and the land cover type. Is it pervious? Is it impervious? And a way that we've done this with students is taken a spray bottle and we just had them walk around outside and say, spray the ground. What happens to the water? And they can notice the water flows over the surface, it's impervious, or the water seeps into the ground and dirt and mulch. And we also can do this in a classroom if we don't have time to go outside by using materials. Here's a rock, here's a sponge, here's a patch of grass, here's a plant. Here is something metal, a paper clip. What happens to water? Again, just to introduce that terminology, pervious and impervious. And so once we get to that point and have done that, we can search for land cover, and I'd recommend doing land cover and then community. There's different layers depending on where you're located. Because this is Chicago, Illinois, this is one of the more mapped areas. And so this is available for Chicago. So I'm going to select land covered community. Again, there's a ton in there. I would recommend searching it at the top bar. And then it pops up as an option, and hopefully it'll load soon. It should load automatically. Fingers crossed. It should load. Yeah, there we go. So we can see here all of the different layers, whether it's pervious, impervious, the type of land cover that exists. And students can kind of get a sense of what's happening in their community, in their school, because they're there every day. So it shouldn't surprise them of a building is going to have a red area. It's not where it's going to be something that's impervious, whereas there's some green space like on the football field or in the middle of the track. But then we let students kind of play around. They can zoom out. They can really see their area and explore nearby. What does the land look like? Because a lot of students, especially in middle school, don't have their license yet, and they're not actually exploring their communities anymore. They're not out on bikes. They're not out running around. And so just being able to give them the access to the information is, again, that could be an activity in itself, is just exploring this land cover map. And what does that mean for how water moves around us? We're going to speed through this even more. One of the cool tools is looking at the measurement aspect. And so let's see if I can find the high school again. And you can click on this sum button at the top and you can take some measurements. And so if I click on that, summarize my area, I can select land cover or land cover change if I'm interested in maybe in the last 5 years, because I think there's 2019 data, 2014 data. I can do some comparisons, but I'm going to select, yeah, I think in this location, the 2019 data, my summary by unit, I'm going to select just draw an area because I want to specifically draw it over the school. And then I'm going to press and drag and draw an area using my mouse. And then it's given me that, and then I can say calculate. And it throws back at me the land cover type, the area, so the kilometers squared, and then the percentage. This is information which in the curriculum we use later, where we're delineating the amount, like the area which is contributing to the water, to the rain garden, that we can come back into EnviroAtlas and actually get area from that's around us with also the land cover type, because it's going to affect the runoff coefficient, which goes into the calculation. But again, EnviroAtlas, initially great tool just to look at lots of different layers that students can explore and that you can use for other reasons too, not just this one project. And then again, the summarize area we can come back to, but I just wanted to show you that it's there in case we don't get time to explore it later.
So if you're feeling a tiny bit lost, that's okay. In the curriculum are the instructions for guidance, and also recognize this entire session is being recorded. So you can go back and listen to Lauren again if you missed getting, so she's going a little bit fast because we have limited time.
Let me see if this will just pop up. I'm also going to pull up right now the AGI education page. I know that it's linked in the agenda, but in case that gets lost, you can always go to the AGI's education page, education and outreach, and then K-12 resources, rain garden curriculum. And then the curriculum that I'm going through is right here, the curriculum outline. There's 2 specific lessons, and then all of these tools that most of these tools I'm going to go through are listed here. So like mapping tools, I would consider EnviroAtlas a mapping tool. And then there's a guide. So for teachers and students that want to go step by step what I just did, there's a step-by-step guide. Same with ArcGIS, which we can go through next briefly. And I might just show that one really quickly up on the screen, but you can get topographic maps. And we've done this with students, especially high school students. Middle school students might be more iffy because they haven't gone through topography and map readiness. Sometimes at the time that we've had teachers do this in the classroom, but it's an option. And then we have water data in here that you can use with students, weather data. So there's just a collection of data resources that relate to this project. And then one more that I don't think is up right now, but again, just a good home base about where to go. 4 more directions about this curriculum, again, because I am going quickly. So another data tool that I think that you may have used is ArcGIS, and just using ArcGIS, I'm just going to Google ArcGIS Downers Grove, Illinois. And typically, I know that I'm probably going to get some flack for this, but typically I just do Google whatever city I'm looking for in ArcGIS because the maps pop up that I typically want. And I'm not an avid GIS user. So I'm going to find this location, and then because Downers Grove, again, every city is different, but a lot of urban areas have like landing pages for a lot of the maps that landowners use. And so I'm just going to click on Parcel Navigator and we'll see what pops up. And again, you can do this for your location. Again, typically there are maps and you can search once you're in ArcGIS, you can type in your location and the map that you're typically looking for. I'm going to specifically look for a layer, and I'm kind of far away right now, so I can't really see. Layers, I want to get contours, and you can type in, like you can search topography, contours, it's always something different. But I'm looking for contours, and hopefully we're going to get a topographic map pop up. Let's see, add. Maybe I'm too zoomed out. Yeah, there we go. So I can zoom, you can zoom in and you can explore. So if you're looking at building a rain garden with students, Maple, that's too south. Sorry, navigating far away. So you can look at a map with students and think about, because again, by this point in the curriculum, you've already looked at how water moves. And so you can get a sense of, okay, how is water moving near our school? I'm just going to go to this location because I can't find where I am right now, but you can type in your address. So we can think about, okay, if I have these contour lines, and again, this is assuming that your students have looked at topographic maps before, and we've worked with middle school teachers where they take a break between introducing stormwater runoff and looking at topographic maps to introduce topography and how water moves across topography and landforms. And so you can get students exploring their area and think, okay, if I want to make a rain garden, which is then going to really help catch water and slow it down, where would I want that to be located? A great conversation to have with students, probably not at the top of a hill because not a lot of water is going to filter down. It's only going to catch the water that enters the rain garden. So instead, look for a lower lying area. And would you want a lower lying area? Maybe off of a really pervious area that's already grassy and maybe catching some water? Or would you maybe want an area that's at the bottom of a street, which is going to have, again, pavement filtering water? Or tennis courts are a great location because normally there's already infrastructure to catch a lot of the water running off of the streets or the hills or the parking lot. But a tennis court, they haven't really maybe thought about that infrastructure of all that water running off of like 10 tennis courts out back of a high school. So that's been a great and a really successful area to build a rain garden when it's downhill from like a tennis court area. And so you can get students interacting with the map and kind of being able to, again, just get exposure that these skills are important, that these people have careers looking and building maps like this. And it's just that exposure to some of these platforms that some students need to become more aware of the issue and to become aware of the career so that as they go forward in their education, they have that light turned on and they start to notice things. All right, I'm going to pause because we're kind of at the mapping component end, and hopefully you've had time to maybe navigate at least one of these platforms a little bit. How are we doing so far? Lolita, Alton, Bertha, Mark? Okay. Shelley, let me know if you have anything popping up. I'm not seeing the chat right now, but I'm sure Don and Carla will keep me updated. Okay. So I'm going to hop off of here. And after looking initially at maps with students, is we typically end this type of session with pick 2 locations. Where would a rain garden be best located? And again, it's thinking about where's the impervious area, the surface area from Enviro Atlas. So the tennis courts, the parking lot, maybe the downspouts of a building, which is funneling tons of water still like into the grass or into the parking lot. And topographically, what does it make sense to install a rain garden? And so students end with thinking about maybe 2 locations. And then from there, we really get into the soil analysis. And this is where we'll spend some time doing a little bit of hands-on things. We at AGI are working with NRCS, the Natural Resources Conservation Service, to really help integrate soil into curriculum, because it's a topic that's so important, but is so I don't want to say ignored purposefully, but it's not integrated into like NGSS for, let's say, or into state science standards. And it's so connected to so many of the science skills and so much of the content, but again, not explicitly. And so if we can incorporate soil, we typically try to. And it's such a great way to get hands-on. Kids love, like, even I was in a school a couple months ago, and we spent like 30 minutes with the kids just digging in the dirt because they'd never done that, which is wild to me. So just a great way to get them really tactile and invested into the subject. So in this curriculum, we look at soil texture, and we'll talk about soil basics briefly in a second. You can do an infiltration test, looking at Web Soil Survey, which is an overwhelming data platform. And we'll talk about a couple aspects of that because it's beyond even what I think normal people can use with it. But it's so great. So much information. And then looking at field tests too with students out in their community. So soil basics, just again, I would spend a whole course on this or whole class on this with your students, just getting them interested in soil. But soil is basically broken down rock. And so I'll ask you first is, I already said one thing, broken down rock, but what is soil? And I'm going to ask for answers too. So think about in your head, what is soil? What makes up soil? And I'm curious as to what our people think, besides broken down rocks, which I already gave away one of the components, minerals, broken down rocks. Broken down plants, organic matter. Great, we've got 2 of the 4. There are 2 left. I'm going to keep that categorized in organics. It was broken down animals, decomposing. Yep. So organics, we got plants, animals, broken down matter, and broken down rocks. Shelley contributed liquids. Wonderful. Our 3rd component is water. Because think about what's between all those broken down rocks and broken down organic matter. There can be water, but if there's not water, what is there? Air. 4 components. Great. So we have all these porous spaces in soil, which most students are not thinking about initially. And there's all these great lessons from SSSA, which is the Soil Science Society of America. They have tons of lessons about soil and how to integrate it into the classroom. But they have one cool lesson about, like, imagine being in the soil and all these like little animals and microorganisms and everything that can be upside down because it's a 3-dimensional environment. It's great. Anyway, aside from that, we have 4 different components of soil. Soil is formed. There's a cool acronym called CLORPT. It's based on the climate, the organisms, the relief, which is the topography, the parent material or the rock it comes from, and then how long it's been forming. And based on all of those 5 factors, it forms in different amounts. We get different horizons. There's different colors, tons of different components of that. And we're going to talk today just about one of those components, which is the mineral aspect or the broken down rock aspect. And that's soil texture. So kind of focus on the right side of the screen where we have those particles in the top area where you have sand, silt, and clay. And those really are just size fractions of minerals. And so I bet you didn't know that there was a definition for sand, and it is a specific size of broken down rock. Same with silt. It's a specific size, and then clay as well. So there's, based on the amount of sand, silt, and clay that's in a soil, it's going to behave a certain way. And so we're going to do a quick, definitely quick, hands-on activity where we have samples of sand, silt, and clay. And I always have students just getting really hands-on. And it's been interesting because even more recently, students don't want to. And so we give them gloves because they have kind of touch issues and sensitivities. And so know that with your students, there's honestly been at least one in every class I've been in so far, but having your actual hands on the soil is best to kind of feel the particles. And there's different ways that you can interact with soil texture. You can just, again, we typically just let students play around for a minute just because they're going to do that anyway. So let them give them a minute to just kind of play around, which we'll let you do as well. But then you can actually look at investigating soil texture. And I bet you didn't know there are soil scientists that just go out into the field and look at soil and classify. And kids don't even know that's the job. Go outside and look at soil, dig a hole, use a drill, and that could be a job in itself. Being outside all day, most of the days, how wonderful. And so when you look at soil texture, you can do it in a lab where soil scientists scoop about a soil, they bag it, they send it off, they have the lab run the analysis and they get the results, but that's expensive and it takes a lot of time. And sometimes they just want to know what the soil is right away, most of the time. And so they actually just use their hands to figure this out. And the experience comes from doing this thousands of times, and they can be pretty proficient at texturing soil. So we're going to do a modified version in 10 minutes. And so you guys are going to definitely become experts. So the first step that I want you guys to do, play around with the soil, feel it, see what your initial assessments are, and then try and determine the soil texture. And I'll leave these directions up. And Shelley, in the handout, there's a link about how to do soil texture in a jar, and that's by measuring the settling of the different particles. And so in the document, there's, I think, 5 or so images where you can actually calculate the texture because sand, silt, and clay settles differently. And so you can do a quick activity, and I have images of this for you guys to look at too, where you can take a jar, fill it with soil, fill it with water, shake it up, and then let it settle. And because of the different size of the particles, the sand will settle within a minute, the silt settles an hour later, and then the clay 24 hours later. And you can actually measure that and put a quantitative aspect on soil texture. So you can have fun with that while we do it at the hands-on. But for soil texture, first try and make the soil into a ball, and it's got to be kind of moist soil. I have them, I think, ready to go, but there's also a jar of water where if it feels too dry, add a couple drops. Do not add more than that. Otherwise, we'll be having a lot of fun with soil painting. And then after you make a ball, if it doesn't form a ball, it's a sand, and it could be a sand or a loamy sand based on this basic qualification. And then after that, see if you can push it upward to make a ribbon. And I will help with this because that's the trickiest part of the whole deal, is figuring out how to make a soil ribbon. And if it makes a ribbon, does it break at an inch? Does it break from 1 to 2 inches? Does it break over 2 inches? And that helps determine the amount of material, how much silt and how much sand and how much clay is in it. You can see that these categories are fairly broad. Once you know the amount of clay, then you can actually determine this more specific type of soil by looking at how gritty it is, or how smooth it is, or how sticky it is. And really, gritty soil has a higher sand component. More smooth and silky is going to be silty, and then stickier is going to be clay. And it always feels sticky. And so it's getting a sense of, you have to feel a bunch of soil to know like what is actually sticky and what's like, okay, this is smooth, sticky. It's, again, just takes a lot of experience in testing. So we're going to do that now. So if you guys want to get up, come on back. There's dry soil that's in the back for you just to look at. And then there's 3 different soil samples. You're going to get messy. There's towels there. Just wipe it off, and then we'll have a minute to go wash our hands. But take some time, just play around with the soil and see if you can determine the texture. You can feel it, yeah. And that's the sand is always the funniest one, because they're like, well, I don't just feel that the beats just like your breath, because you know that that's type of soil texture. This one is, yeah, that one should feel like a very smooth, yeah. Okay, just imagine like the kid doing this over, and that's typically I would give a student like at my talk, you know, I'll give everyone a sample because it's just. Let's play with some sort of. Yes. It's actually the middle. But I always joke, one of the schools actually had my daughter on me. She was little and wouldn't take a bottle, so I brought her. And they were like, just so you know, this came out earlier from, and they were like, this is babies. But I was like, from the ground. Exactly. but it's a fun, I mean, it just, you know, it's fun.
But now that I'm using safety regulations, they have to get them for us.
Yeah. Exactly.
In order to do that, we have to give them safety lab.
Yeah, but that's the best part of this, is
Yeah.
there's such a good alternative, because even in the middle, especially elementary kids, we typically say, just use soil by texture and have fun. And like follow the procedure, we can modify that, we have the pictures of it, you can't keep this chart, it's like, here's the new picture.
But I think sometimes when we don't want to, they want to do this. Because like, my work is maybe this is another option, but I just want to,
Yeah.
I need to come here.
Yeah, exactly. But the alternative would be to use by the jar. So whenever we've been in a classroom, I would use back images, or I've actually taken the soil and mixed it with the jar and said, now imagine that. So I can show you guys that right now.
My story in a jar, there's students will look at this.
Yeah. And so here's, I can give you guys these, but you can see how the soil particles settle separately. And so there's these sand particles, then we have the silt right here, and then the clay layer at the very top. And so what we can do is you can actually measure the relative amounts. And this gets more to middle school, high school, where you can calculate percentages, and then there's actually, like, you can use the ternary diagram, which is what that triangle diagram is. And it will tell you exactly how much you have. And there's an Excel document from NRCS where you can just type in, I have 10% sand, I have 30% clay. It calculates your silt for you because it's out of 100, and then it plots it so that all the kids can plot their points, understand how this ternary plot works, which is important in geology to learn how to read and utilize a ternary diagram. And this is an easy, I don't want to say easy, it's an entry point to kind of that type of plot, which isn't, kids aren't exposed to typically till college. Oh, sorry. Sorry.
It occurred to me that put the zoom on some of these photos.
Shelley, we'll send you some pictures of what happened. Okay, we're gonna keep going. You guys okay so far? Any other questions about soil? We were talking about the hands-on activity, had a lot of texture. There's 3 different soils to test out, and then we're just talking about the jar pictures, which should be in the Google Doc that's linked on one of the agendas, where you measure the different components, and then you can have kids do that if they aren't comfortable with feeling the soil. Sorry? Yeah, and I'll send it out too. Again, if you have any questions, there's a bunch of activities. Like, I think in the Google Doc, I put a link to triple essays or the some soil conservation districts activity just like this, so you can do it with your students. But again, texturing soil, it's one of the, even with adults, it's one of my favorite workshop activities, and to go in with kids, because it's just so fun to just feel the different soil. Yes. Mm-hmm. Yeah, and the tactile nature, we were talking about how the soil is very similar to like Play-Doh and just being able to relieve stress. And it is doing science right there to be able to, which soil do you want to play with the most? What texture is that soil? There you go. Now you know what to look for on Web Soil Survey, which transitions nicely that we're going to figure out what type of soil is near you. And so with students, we would talk about being able to determine the different textures. We then would look at infiltration. And so if we think about, we have 3 different types of soil, we can add water to them and see how water enters them. And one thing we're not going to have time for today is looking at how they actually do interact with water. And so what you would see, I'll just spoil it for us, that sand, as you may expect, absorbs water, or water can travel through sand very easily. So think of a beach, the waves roll over, the water goes into the sand, and then the waves go back out, and it happens over and over again. And the reason for that is because of the particle size. There's just more larger pores for the water to travel through faster. Then it increasingly gets slower. The infiltration becomes slower as you get more clay involved, because the clay packs tighter, and so the water has to travel a lot more between those different clay particles. And so when we talk about infiltration after doing an infiltration activity with students, so we think about if you're having a rain garden, you want water to be captured and you want water to infiltrate. What soil type maybe would you want, and which soil type would you maybe want to avoid when you're having a rain garden? So students are able to say, well, if you want a lot of water to enter, you want sandier soil because more water can enter the soil versus clayey soil. The water's not going to infiltrate very fast. And so it's going to overflow the rain garden and then kind of spill over the top, or it's just going to kind of sit and be mosquito-y, and you want it to at least drain within 24 hours for it to be an effective rain garden, and drown plants that maybe would be there. So after having those conversations, again, this is not a 5-minute talk with students, it's more drawn out and, you know, interactive. But then we go to Web Soil Survey, which is a great data platform, and I'm going to have you guys go to, and it's going to be, we're going to go step by step because I think it is worth the time. These directions are online. I'm not going to leave them up, but they're there. Just so, again, once you are in the platform, you'll be like, whoa, what's happening? Where do I click? And here we go.
Do they Google web,
So you can just Google Web Soil Survey.
web soil survey?
Yep, and I will do the same thing. Good. So I'm just gonna Google Web Soil Survey. And then I get brought to USDA NRCS's app. On this website, it's also in the links document, thank you. And on the RAINS webpage, but you can scroll down, there's 4 basic steps. Basically, we're gonna select an area of interest, click on a soil map, and explore the soil data. And the soil data part's the confusing part because there's so much data to look at. So we're gonna just look at soil texture because we just talked about texture. So I'm gonna click start. Is everyone on this page that's in the room? Great. Okay, I'm gonna click start Web Soil Survey, the big green button. I am then going to select how am I going to find my area of interest. And again, this is for landowners, it's for scientists, it's for researchers, it's for community people. There's a lot of people use Web Soil Survey. And so because of that, there's a lot of ways to do everything. So for us, we're just going to type in an address and start there, but you can play around with the rest of these ways to get an area of interest. So I'm going to type in, once again, Downers Grove, Illinois, just so that we're all on the same page, and I'm going to click view. And I'm now in that same area of Downers Grove. It's not as intuitive as like Google, where you can't just like zoom in and out. There's a plus button on the top and a minus, and you have to click on the button and then click on where you want to go, and it will zoom in. Or you can select an area and then it zooms into that area you just selected. And I just kept zooming into that Downers Grove pin where it got placed because I just know that the high school is right near that pin. Is everyone here? Downers Grove. Just type an I. You're in basic search, so go to address under quick navigation. Keep going down. Yep. Okay, and then when you do that, you can click on area of interest. And this is the part where you have to select what you want to analyze. Because right now we're just looking at an area. So there's 2 ways to do that. You can do an AOI, area of interest, by a rectangle or by a polygon. Let's just do a rectangle for the ease of today, but play around with polygon at another time. I'm going to select a larger area than I would if I were working, like hoping to install a rain garden. But I just selected a box of a large area so we can see what the map looks like. So once again, once you're zoomed in enough to where you're happy and satisfied, click on this red AOI box, the second to the left of the end, and then select an area. And that's now your area of interest that you're going to analyze. And you can see the blue hash marks that pop up from that. Does everyone have an area of interest selected? Okay, now one thing that we can do, and that soil scientists immediately go to the soil map, and we'll show it, but it means almost nothing to me because I don't know any of these codes and any of these names. One thing that's really helpful though, is to look at like, oh, there's silt loam, there's silty clay loam. I know what that means kind of, and I can kind of get a sense of which is the highest percentage of soil in this area. Okay, I have a lot of this complex, don't know what that means, but I'm going to click on it and maybe it shows me something else, give me all the details about this type of soil. the important thing is the setting. I can learn a lot about how this soil was maybe formed, how it was accumulated. Gives me the profile. Again, information that is good to know, but are your students going to care? Probably not. It's more for our knowledge about the soil. Again, kind of at a level where I wouldn't bring students to at this point, but good adult learning. What I would bring students to, and that are in the directions, are to go to the Soil Data Explorer. It's the 3rd tab. And then it's going to open up all of the different interpretations that I can view. And again, this gets overwhelming already. One aspect that I'll point out is there's this Intro to Soils tab. That is going to be information. It's a good library. I can click on Soils 101. What does this mean? I don't know about soils at all. Here's a great Soils 101 resource. I don't know about forest canopy. What is that? I can click on it and it tells me all about that content and what kind of interpretations can be made. So a good resource to use. We're going to go, so we're back at our Soil Data Explorer. In our area of interest, we're going to collect soil properties and qualities, because that's what I'm interested in. And I know this. I know where soil texture is located. You do not. We have directions for click on here, and then you can get the soil texture. So we're going to click on soil properties and qualities, and then soil physical properties, because that soil texture is a physical property. And then I'm going to scroll down until I get to surface texture. And again, this is just looking at the texture, the 12 different classifications we just looked at with our hands. I'm going to click surface texture. All these buttons pop up again. In the guide, we have click here, click here, click here. So it's done. We have surface layer selected, and we're going to click, you can click view description, and that tells you about the texture that you're going to be displaying, or you can click view rating, and then it pops up the texture map for us. There's lots of information. We can see that there's a lot of similar soil textures in this area. If I click on legend, it pops up what those properties are telling me. So it gives me, again, I can read my map now. And then with students, what I do with middle school students is I actually already give them the map so they don't have to deal with this interface, because it's pretty tricky. And just think about a 6th grader doing this is kind of I wouldn't do this with my students if I were in middle school, but I would give them maps to analyze. And so I can click off some of these features that aren't as important. And then once I have the soil ratings up or the soil types, I can go to printable version. And it says add to shopping cart. You can do that. It's free. It makes it sound like it's not. It's shopping cart, but then you can compile all your reports. With students, I just want a printable version. It's really easy. And I can click view. And then this is ready to share with students. For the rain garden project with the classrooms, we had students having to pitch the project to their administrators. And so in their pitches, they were collecting data and they were presenting their administrators with, look at the type of soil we have, look at our topography. This is why the rain garden would be successful in this location. And this is the information they shared in order to back up their claims. So again, a good soil map that we can use for many different ways. For a rain garden project, this is too far out. I would probably go back. I would change my area of interest. I would clear it. I would zoom in to my school and I could get more fine-tuned data. That way, as I'm having that conversation with my administrator, we can look at the areas more specifically to our school. Questions so far about soil in general? And again, we did soil in like 20 minutes, and that takes many classes with students. So it's just a sneak peek and hopefully something that we can talk more about online or over the phone or as you're working with your students. Okay. After soil, and I know that we're coming up quickly here, but we're gonna get as far as we could. After we look at web soil survey, again, that's 1 or 2 days, depending on the students. We can look at weather. So thinking about a rain garden, now that we have our location picked and we have soil data to back up why that area will work, or maybe we found out that our entire school is built on clay soil. Can we build a rain garden there? The answer is yes. We just need to amend the soil, which makes it more expensive to install, but it still can work, or make it much bigger, or think about the redesign of it. There's lots of ways we can do, but knowing the soil is going to be extremely helpful in the design aspect. Another aspect that's helpful is knowing how much water do we expect our rain garden to be able to handle. And so for that, we would need to know the average storm size that's around us. And so you can look at weather data. There's a lot of options to look at weather data, and it's fairly more intuitive than like web soil survey for students to look at. So I'm not going to go too much into weather data, but we can at another point. So we work with students to look at the average precipitation events and extreme rainfall scenarios. And then we think about how to actually design the rain garden that next day. And so one of the more math heavy components is figuring out how big should our rain garden be? How big does it need to be? So if we're thinking from a cost standpoint from a school, we could make it as big as we want to make it, but is that wasted money, and are the plants going to survive? Because if we're counting on the rain garden to hold a certain amount of water, if we put all this money into plants, most of them will die off if it's too big. If it's too small, then the water is just going to flow over the top, and then it's not going to be as efficient and as successful as we want it to be. And so we would use Enviro Atlas. Once we have our rain garden location, we can use topographic maps and delineate how the area that's going to contribute to the rain garden. And we actually did this with one of our schools by just getting a hose. And the kids were like, well, from the map, this looks like the area. And they wanted to go check it. And it was like, how do you want to check it? Let's bring a fire truck out here and spray water everywhere and make sure that it's like, okay, that's a great idea. How can we operationalize that in the classroom? And they were like, let's get a hose. And the teacher was like, sure, let's get a hose. So we went outside and sprayed a bunch of water and just confirmed or helped them adjust, because what they didn't account for was all the cracks in the tennis court, and that there were all these different topographic issues with the tennis court where they thought all the water would run this way, but really it was running to the sides and not streamlining to the rain garden. So we had a trench location. It was a whole thing. So actually field verifying the data is an important part with students that sometimes we skip for time, and that we're looking at data. That's great. Let's use that as is and then keep going. But if you have the opportunity to validate that data in the field by saying web soil survey said we had clay soil, let's go outside, because we know that that data doesn't mean that a scientist was at our school validating that that was the data. It was from observations, right? And looking at different information that they then could make that claim. Being able to validate the data is empowering to some students, because sometimes we found that the data is incorrect and it's like, oh, we actually have sandy soil right here. Probably because when they built the school, they didn't just use the original soil after they built it, that they put some backfill on top. So lots of good discussions to go on related to this. Related to the delineating to the contributing area is that depending on how the material the water flows over, it's going to absorb or run off differently. And so there's these runoff coefficients that have been assigned for the different types of land cover. So you can see that if it's like a pavement, there's going to be a lot of runoff. If it's more pervious, it's going to be less runoff. And so students can then map what the area is what they consider the area for land cover, and use Enviro Atlas. And then they can actually calculate the predicted runoff area and the volume by calculating by the average depth of rainfall. So this is one of the more math heavy components of the curriculum. And I've had teachers in middle school just skip it all together. And I think that that's fine. It's not a curriculum where you have to do every single aspect. I'm going to pick and choose what works for my students and what we need to do to get the job done. But again, that it's heavily modified. I'm able to work with people to modify it for your situation. So just let me know if you want to work with me to kind of do that. And then design the rain garden. This is where some of our more artsy students that I've worked with really get involved, because they like thinking about what plants are we going to do and how does that look in the wintertime and look in the spring. One of the school's biggest issues that I've interacted with is aesthetics. So if we're going to plant this rain garden in the front of our school, because topographically and based on the land cover, that's where it makes sense, right after the parking lot. I don't want this to be like a rock garden filled with weeds. So we want it to look pretty all year round. What plants are we going to plant that are going to bloom at certain times of the year? What's the height those plants are going to be? What's the maintenance? What do we need to tell our staff about how to maintain this? There's a lot of different logistics that go into a rain garden that if you're not going to actually install the rain garden, you probably could ignore. But if you are going to pitch it to an administrator or want to install, you definitely want to think about labor. You want to think about maintenance and think about what it's going to look like throughout the year. There are different apps. One good one for Illinois, which is again, where we're piloting this project, is the Plant Finder app. It's very cool. Talks about like the zones for moisture. So if you think about a basin which is what a rain garden is, the base of the rain garden is going to be the wettest. And so you want moisture loving plants to be planted there that can tolerate being underwater for up to 24 hours. And then versus on the top edges of the rain garden, that's going to be the drier areas. You want your more drought tolerant plants to be planted at the top. And so there's a lot of good biology components to bring in. And one of the schools we're working with, it's the science club, and the biology teacher is really taking the project on. A lot of logistics that students can plan. It gets them thinking outside of just being, you know, an earth scientist or a geoscientist. And then after approvals, you have installation. So this is one of our schools that just installed in May. Our another school is installing in August because their school didn't want to deal with the maintenance over the summer, which is very valid. So set yourself up for success. You don't want to plant a whole rain garden, spend all this time, and then no one water and have it dry up over the summer. So this was great. I'm excited to keep working with the school because the next aspect is, and I'll come back to this at the end if we have time, is monitoring a rain garden. Now I'm going to pause for questions because we have 10 minutes left, and then probably speed through this faster than I would have liked. I know. Who would have thought I had too much to say? Do you guys have any questions so far just about the curriculum aspect about in getting students to understand rain gardens to help them plan one or design one? Okay, we can have more casual conversations too about how you think this might fit into your curriculum, whether you actually do it or not. But again, tweaks that we can make because it was a pilot project. So, and one of the things that AGI loves to do is revise. And so if there's improvements to be made, we're always happy to do that. So if you go back to your school and you do this, like, I wish this happened. Great, let's do it and let's embed it in. So always provide feedback when possible. So monitoring a rain garden, I'm very excited because when I was with the EPA ORD, I did this. We installed rain gardens, we were monitoring, it was awesome. And now I'm bringing that into schools, which I'm really excited about. And so there's ways that we can monitor a rain garden that I have planned, and I will let you know how it goes in the wintertime. We are going to install a staff gauge, which we have in this rain garden. You kind of see it in the middle. So this is the same rain garden, just from different images. This you can see parking lot that's downhill. Uphill is the tennis courts I've talked about, and there's a trench right here. So all the water was going towards the parking lot. We trenched it, and then the water comes in this way. You can see it's filled up because the rain event was heavy. It was a heavy rainstorm, and you can see in this picture better than this image that there's a staff gauge in the middle, this white hole, and then there's also a piezometer or a stilling well next to it, which I'll talk about in a second. So just by filling up the rain garden with water, when the rain garden gets filled up, you can go and actually put on your waders or your rain boots and go and look at eye level and take a measurement of how much water is in this rain garden at this very moment. And that's just by using a staff gauge. Students can do that. The problem that we found so far is that students are in classes during the day when it rains. Who knew? And they don't want to go out in the rain to take measurements. So this is an idea that we have, is to use a trail camera and set it up and be able to actually figure out if we can use trail cameras to monitor water level with a staff gauge. That would be a much lower cost and lower time than using a stilling well. And so that what this is using a tool called a pressure transducer, and it sits inside of a pipe and it measures the pressure above it. And when it gets filled with water, you can imagine there's more pressure on top, and then we calibrate and figure out based on the reading of the staff gauge and then using the transducer as well as how much water exactly was above the transducer. And it again helps us determine the water height and water level. So we're going to be working with students to figure out how well the trail camera project works with the staff gauge, and then also monitor the performance of the rain garden. So more to come, hopefully at the end of the fall semester. But I'm excited about that project and getting kids involved in data collection. The third part, which is again another passion project of mine, is we've worked with a lot of schools, and I've talked with a lot of schools that have rain gardens or had rain gardens, and then the teacher left, retired, and the rain gardens kind of went away because no one cared about it anymore. And so how can we keep it current, and how can we keep the importance of having the rain garden in the school and use it as a teaching tool? So it becomes a tool every year that teachers and students can then go out and use. And so this will be really quick. There's a paper that we have out about this project that I can send you a link to. It's on, I think, our website, but it's two different parts of a curriculum. I'll go through one, which is looking at surveying the rain garden. So you can take surveying. We first would introduce again stormwater runoff. So this is assuming that these students were not involved in the installation. I'm envisioning there's a junior class of AP environmental science or of earth science, and they've looked at a rain garden, they've installed the rain garden, they're happy with it, they move on. The next kids come in and go, cool, we have a rain garden. Like, that's great. They don't have to look at the data because it's already installed. So once again, introducing stormwater runoff in the rain garden in general, and then going through and be like, now, what's the purpose of our rain garden and does it work? And so this is the curriculum that kind of goes through those details. So after introducing the importance of stormwater runoff in rain gardens, they introduce surveying, and there's this cool video by Practical Engineering. I'm on mute right now, but I'll kind of just skip through it. And it goes through easy ways to, like, the importance of surveying, and then easy ways that surveying happens. And so, and how to do it. And so one way that we've come up with is just to use meter sticks and measure from an elevation down to the ground. And you can do this with, again, we practice in the lab, again, to get students familiar with the procedure, and then we bring them out into the field. And in this instance, we had spent the time, because we had it, we are not educators at this point who are overworked, to set up transects along the rain garden with rope. And then students actually went out with meter sticks and measured the height from the rope down to the bottom of the rain garden. And that was a fun decision that students had to make. Is it down to the bottom where the top of the rock is, or the bottom of the rock where the soil starts? That was a fun discussion too, because that talked about the discrepancy between the measurements of the groups. Another way to do this that we've done is to put one of those levels out that have the lights. So that set the level out in one location, and then you again have your meter stick and you're going through and figuring out, where does that red level light hit my meter stick? Which is equivalent to what geoscientists do, or geologists do, is they take stadia rods, which are really tall meter sticks essentially, or just tall measuring devices, and they're looking through a scope and figuring out exactly what height that scope is at, and then calibrating and figuring out the elevation. So it's, again, modifying the procedure that real scientists are doing with materials that teachers have or can rent easily. So we had kids do that, and then they graphed their measurements, and then they created 3D models of the rain garden, of the depression. Great math activity. Our physical science teacher was just appalled at her students in a good way, of like, oh my gosh, you can graph and cut and create models now, but you couldn't with just like a question. So it was a wonderful activity to do to really bring their data to life. And it was also an interesting discussion because one group built their data upside down, because when they were graphing it, they graphed height, and height is tall, but they didn't conceptually understand that they were measuring from a location down, they were measuring depth. And so that was a fun discussion to have also about how to construct the model. And then after we made the 3D models to really just get the sense of that it was an area, we then had to talk about the volume. And I'm going to speed through this way too quick, but think about, if you were a student looking at this and you had these graphs, how would you calculate the volume of the rain garden? But you don't know calculus. You're a 7th grader, you're a 9th grader, but you get to do calculus and you don't even know it. And so it's a great integration of the math skills, and they don't even again, they're not even realize they're doing calculus. They're thinking about, okay, how do I figure out the area of this transect? And so the student work is on the left. That was my work on the right. But again, the kids very much surprised us, because we said, like, figure out the area of this. And we were debating, are they going to just think of this as a rectangle? But some kids got really precise in every triangle they were calculating to figure out the area. And then the discussion of, well, how thick is this slice, so that we would have to make up the entire, because this is just one little slice, but we got to figure out, multiply by the thickness of the transect. So it was, again, a very fun math application that kids were tricked into doing, which was wonderful. And then again, you can do this on a computer as well, using Google Sheets or whatever, by putting the data available on a platform, and then having kids, again, do the work digitally. So lots of ways to involve students. Yeah.
Now they have the experience to actually keep that.
Mm-hmm. Exactly. Scaffolding to at its greatest. Yes, thanks, Bertha. So again, it's a great project. I'll wrap up with that. And one last, because I know we have 3 minutes, I'm going to show this, even though we don't have time to do it. But one of AGI's big initiatives is just career awareness and how important it is that every unit or every lesson, you can just mention or talk about a career, because kids don't even know what careers are out there. I didn't know that people were soil scientists, and I was a chemistry major until I was like, how did I, a chemistry major at Vanderbilt University, not know that soil scientists existed? Like I just had never been exposed to it miraculously. And so just again, mentioning the different careers and the people that do these jobs is so important because you never know where students are going to go. And so with that, AGI has a geoscience career explorer that's tied to the sustainable development goals, as controversial as that is. We're very excited about it because, as we mentioned, students now today are really tied to action. And so this is an issue. I want to learn chemistry, sure, but I want to learn chemistry because water chemistry is really, really important to me. And I want to care about clean water. And so this is a platform. The link is in the notes, and we're coming up on lunch right now, but if you want to stay now or later today, we have time, we can play around with it. But it's really easy to use. You click visit once you're actually in the app, and then you can click through kind of which sustainable development goals you care about, whether it's good health and well-being, or clean water, number 6, or life on land, number 15. And then you can click on the skills that you like to do, like go out into the field, or I like to work by myself, or I like to work on data. And then it gives you a list of geoscience plus careers, because not every career you think of as initially related to geoscience, but a lot of them are, like tourism. If you're a tourist, or if you're a tour guide, tour leader, that having some geoscience knowledge is going to really help you be successful in your career. So it gives a list of careers for kids to explore. And we have educator resources to use in the classroom related. And with that, I have probably less than a minute to answer questions. And thank you guys for coming. And obviously I'm here until tomorrow with all of you. So let me know. Yeah.
This is really cool. I'm one of the fellows.
Mhm.
Does anyone here have a good geoscience background? Yeah.
Sort of, yeah.
I'm a geologist. I mean, and like a lot of these things we're going through, like stuff that I've done, like all of that, like the tertiary diagrams, like there's fun watching, like I've gone through soil science classes and just seeing these things like how I don't know. This is really cool. And
Thank
it's
you.
like directly applicable to a lot of geology. You don't think of as something that is sustainable or related to stuff, but there's a lot of things right now trying to figure out sustainable in the future. Even the things that are less sustainable side of things are still going to be like your cast, like mining and things like that. That's
Exactly.
cool to see.
Good. Thank you. Thanks, Joseph. All right. Shelley. Is she not there anymore? Okay, she left. Great. Thanks. Thanks, Shelley, for participating if you watch the recording. And with that, I think we're going to head to lunch. We'll be back here in an hour and a half. If you guys have questions again here, just let me know, and feel free to email me for anyone watching the Zoom link later.